Well, I think we're going to have to put those pieces in first. This program is actually a certification program that was developed with Windmill in the Department of Education to really promote offshore wind energy in the classroom. There is an initiative that has been supported through a grant to really kind of push this in our schools to kind of develop the workforce and keep our kids in Rhode Island and offer job opportunities for them while they are here in Rhode Island. They are going to be going over things like Betts's limit, which has to do with the amount of incoming wind energy and trying to really harness that energy in as much as possible. They learn about torque, gear ratios, angular velocity and angular momentum, and really apply those in a really practical application kind of way.
Voltage was higher on 4 blades, but amperage was even lower.
Okay. You know, I can do the calculus.
They are designing wind turbines that need to essentially harness as much power as possible. They've got a set limitation, so they've got a particular wind tunnel size that they need to stay within, and a couple of building restrictions to keep things safe. But they're trying to really, I'm going to say, push the limits and develop something so that way they've got this turbine.
The voltage was about the same, but the amperage was going up more.
They come into class, they get to work right away. It's actually a challenge to stop them, to be able to give them the announcements for the day and tell them what the goals and objectives are, because they jump right in and are working with each other, and the conversations that they have and the ideas that they have, really it's truly amazing what they've been able to do with this.
Everyone else's group's gear system work off like metal gears and really bulky gears. We kind of wanted to go a way that would make it very compact and still be easy manageable for any type of changes and stuff like that. So currently our gear system is all made out of NXT Lego bricks.
Our wind turbine, we're going by a philosophy of work smarter, not harder. So what we're trying to do is we're using the rim of a bike wheel, and we're going to put foam cord wings over it and reinforce it by using zip ties.
We are trying to build a turbine that has blades we can rotate while it's functioning.
Everyone loves it because it's so far out of the normal learning, where it's either like in a classroom reading about Hamlet, but this is exactly building like gear systems, and it's great.
When she proposed this project, our teacher, I thought it was awesome because I like the idea of construction while also incorporating math.
Let's say these 3 panels, they don't move.
When I heard about this, I was super excited. I was like, oh, now's my chance to really do something I love to do.
For going into mechanical engineering, this type of stuff, this hands-on learning is exactly what I'm looking for.
I do take a lot of different classes and I like a lot of them, but this class has been unique with something I love to do.
They've been able to not just work on the science side of things, but just that practical, real-life set of skills of how do I make this happen? Teamwork, project management, communication with one another has been a huge one. And all of those things are key skills that they're going to need in the workplace.